Look at adoption of this type of technology, the adoption of the graph and NLP. One of the biggest struggles that people have been going through is how do I connect my data in order to leverage this type of technology? That creating yet another data store within the organizations where they've already spent millions of dollars in order to be able to build up these large data warehouses and data lakes and go, well, get lots of really great insights by leveraging the graph, but you got to take everything out of that and stick it all into another repository is kind of a bitter pill for people to swallow. And so that's why we really invested in trying to build this data virtualization capability directly into the platform so we can represent data within from its existing silos within the graph so that people can write graph queries, they can look at graph embeddings, they can look at all the ways they can leverage data through the graph, but don't necessarily have to do all this kind of extract and ETL and load and transformation into the graph itself. And that's been a huge help in the adoption, especially as it relates from the kind of ingestion side. But what I think is interesting is we've seen a lot of evolution on the consumption side, people consuming out of the graph. And one of the ways that I've seen that really change recently has been the idea of looking at natural language as a way to interact with the graph instead of a more structured query language, sort of like Sparkle or SQL, but people wanting their end users to be able to ask natural questions in the English or language that they're used to using, and then being able to get consistent or coherent or related pieces out.
That tells you that people are now looking at the other side of things, right? So if there was data or other semantic data that was not in the graph, then nobody would ask, how do I query it, right? So if somebody says, I want to query it, means that they did something to get semantic data, and they're most probably using some kind of a conversion like NLP to take the unstructured data, convert it into semantic structured data. So now their question is, okay, now I have all these pieces. What do I do? How do I query it? What can I do with it? So usually our pipeline, our implementation pipeline starts from ontology development. You create the shape of the knowledge that you want. You create the important concepts that you're looking for, the important relation between those concepts that you're looking for, and then create that into a formal structure, usually an OWL ontology. With that, just like how you have this virtualization process where you can take this, the legacy data, and without having to bring it in, you can still connect to it. Similarly, we have a process for taking the ontology and automatically training the NLP, because it's very hard for people to create an ontology. The ontologists sit and create an ontology, and then we tell them, you know what, the same piece of information now, train the machine as well, right? There's no reason why the ontology cannot be used directly to create or train the NLP.
Well, Mithun, it's been great talking to you today. I look forward to in the future digging into some of these topics deeper. I think that we can have some great conversations around ontology development and other ways that this technology has been adopted, use cases, et cetera. So